Do you use a smartphone? How about a computer? If so, you use databases every day. When you check your bank balance online, you use a database. When you order food through an app, you use a database. Even when you watch a video online, you're using a database. Databases are everywhere in our digital world. They are the hidden engines that power many of the applications and services we rely on. But what exactly is a database? A database is like a container for information. This information can be anything: names, addresses, product details, financial transactions, and much more. Databases are designed to store large amounts of data and make it easy to access and manage. Imagine you are a librarian, and you need to keep track of all the books in your library. You could write down the title, author, and publication date of each book on a piece of paper. But what happens when you have thousands of books? It would be a nightmare to manage all that information on paper. That's where databases come in. A database allows you to store all this information electronically in a structured format. You can easily search for a specific book by title, author, or ISBN. You can also sort the books by genre, publication date, or any other criteria you choose. Databases are essential for businesses and organizations of all sizes. They help us manage customer information, track inventory, process transactions, and much more. In today's data-driven world, databases are essential for making informed decisions and staying ahead of the competition. Just like there are different types of libraries for different purposes, there are different types of databases designed for specific needs. Some common types include relational databases. These are the most common type of database. They store data in tables with rows and columns, much like a spreadsheet. Relational databases are very structured and are good for storing and querying data that has a clear relationship between different pieces of information. For example, a relational database might be used to store customer information, where each row represents a customer, and the columns contain data such as their name, address, and order history. NoSQL databases. These databases are designed to handle large volumes of unstructured data, such as social media posts, sensor data, or log files. NoSQL databases are more flexible than relational databases and can handle data that doesn't fit neatly into rows and columns. Cloud databases. These databases are hosted on cloud computing platforms like Amazon Web Services, AWS, Microsoft Azure, or Google Cloud Platform. Cloud databases offer scalability and flexibility, allowing you to easily increase or decrease your database resources as needed. Graph databases. These databases are designed to store and query relationships between data points. They are useful for applications such as social networking, recommendation engines, and fraud detection. Each type of database has its own strengths and weaknesses, so choosing the right one depends on the specific needs of your application. Section 4. How do databases work? At their core, databases allow you to perform 4 basic operations on data: create, read, update, and delete. These operations are often referred to as CRUD operations. Create. This involves adding new data to the database, such as creating a new customer record. This involves retrieving data from the database. For example, you might read the database to display a list of all customers or to find the details of a specific customer. Update. This involves modifying existing data in the database. For example, you might update a customer's address if they move. Delete. This involves removing data from the database. For example, you might delete a customer record if the customer closes their account. To interact with a database and perform these CRUD operations, you typically use a language called SQL, which stands for Structured Query Language. SQL provides a standardized way to communicate with databases, allowing you to perform tasks such as retrieving specific data, inserting new records, updating existing information, and deleting data. For example, to retrieve all customers named John Doe from a database, you might use the following SQL query: select asterisk from customers where first name = John and last name = Doe. Section 5. A world powered by data. Databases are the backbone of countless applications we use every day. They play a crucial role in various industries, including e-commerce. Online retailers use databases to store product information, manage inventory, process orders, and track customer purchases. Banks rely on databases to store customer account information, process transactions, and manage financial records. Healthcare hospitals use databases to store patient medical records, track medications, and manage appointments. Social media. Social media platforms use databases to store user profiles, posts, connections, and interactions. As our world becomes increasingly data-driven, the importance of databases will only continue to grow. This means there will be a high demand for skilled professionals who can manage, analyze, and interpret this data. The field of databases offers a wide range of career opportunities, including database administrators, data analysts, data scientists, and database developers. These roles require a strong understanding of database concepts, SQL, and data analysis techniques.